Hello. Am I clearly audible?
Assalamu alaikum, sir.
Yes, sir.
Okay. Then we can start our today's lecture on gradient boosting. The gradient boosting is one of the powerful boosting algorithm. In gradient boosting, it also utilizes some of the excellent boosting method. Again, we need to construct the weak learner, and then we will increase the performance of our weak learners through some boosting mechanism. And gradient boosting, it will use the gradient to find out the shortcomings of the previously trained weak learners. So here two things, the gradient and another one is boosting. As I already mentioned, that boosting refers to a family of algorithms where we create the weak learners and then boost up using some of the methods, utilizing some of the methods. And gradient here, that means we will utilize the shortcomings of our previously learned weak learners using the gradients, using the gradient. So that's why the name of the algorithm is gradient boosting. It's one of the powerful learning algorithm, and based off the gradient boosting algorithm, specifically the updated version of gradient boosting is extreme gradient boosting, that is built based on the base of gradient boosting. It can do like regression. We can apply gradient boosting for classification and for ranking of features. Okay. Then in this lecture, at first we will discuss about how gradient boosting is different from the ADA boosting, and then we will discuss about the theory of the gradient boosting, and then we will discuss one of the example with a database. So if you can remember our last lecture on ADA boost. So in adaptive boosting, what usually we do, we try to build several weak learners. Okay, several weak learners. Let's say this is the data set. This data set is given, and then it will try to find out the best discriminative feature, and utilizing that, it will try to find out a weak learner. Okay, so let's say it will just find out a weak learner. There is a H1, and the H1 it will split our data set, or we can say it can perform also the classification. Let's say this part is this side, that is the left side is positive and this side is negative. Then we can see that H1 weak learner successfully classify these two positives, and this side is negative, so that means we can say these are the misclassified positive instances. Misclassified positive instances. But we can see that actually this weak learner successfully classify few of the positives. Okay, few of the positives. Then what in AdaBoost what usually we do, we have to identify the misclassified instances. Here we can see three positives are the misclassified instances, and then we increase the weights of these misclassified instances to pay more attention to those instances, so that maybe if we can construct the next weak learner, then the next weak learner can successfully classify those instances. So the hope we keep in mind that maybe next weak learner will classify or successfully classify or try to classify the misclassified instances by H1. So that's why pay more attention means we have to increase the weights. So here you can see actually we have increased the weights of our three positives. It means we need to pay more attention to these three instances. And then we again build the second weak learner based on the output of our first weak learner. We construct the second weak learner, and this weak learner, maybe you can say H2 is our next weak learner. This side is positive and this side is negative. And then we can also see that the second weak learner successfully classify these two negatives, two negative instances. But as it mentioned that this side is positive, but actually you can see three negatives are there. So these are the three negatives. Those are misclassified instances. Those are misclassified by H2, that is our second weak learner. Okay. Then again, we need to pay more attention to these misclassified negatives. So we can say we have to increase the weights of misclassified negatives here. These are the misclassified negatives. Those the weights are increased. Okay? Increased. Now this is our data set, and then we have to apply or construct third weak learner. So this is the third weak learner. H3 is the third weak learner, and then third weak learner, we can say if we can say this side is positive and this side is negative. These three positive instances are successfully classified, and these three negatives are also successfully classified by our third weak learner. So if we combine the effort of our first, second, and third weak learner, then actually we can see that after combination of these, we will get the first weak learner is this one, second weak learner is this one, and third weak learner is this one. So we can see that it is successfully classify all the positives and all the negatives also. So actually what we did here, this one is our H, so this one is our H1, this one is our H2, and this one is our H3. And we can see here this is 0.42. This is the weight. For final classification, what usually we do, that is we consider the weight of each and every weak learner and times the age. Okay, and then this is the weight of our second weak learner times the age, the result, and then weak learner. This is the weight of the third weak learner. There is weight of the vote or amount of say. I think in our last class we have explained this one in details. So finally, we can see there is the, okay, if we sum up these things, then finally we will get the result. Okay, so sometimes maybe we will get positive, sometimes we will get negative. That's why the sign is important here. Okay, so the class levels finally we will define based on the sign, that is whether we get the positive value or the negative value. Okay, in AdaBoost usually we do that. But what's the difference here in our gradient boosting? So in gradient boosting, you can see the shortcomings are identified by the gradients. But how about the AdaBoost? The AdaBoost, the shortcomings are identified by high weight data points, as we have already seen here. That is, okay, these are the misclassified instances. So this is kind of the shortcomings. So then we will just increase the weights of these instances. Here you can see these are three instances with increased weights. And so shortcomings are identified by the high weight of the data points. But in case of the gradient boosting, what we will do, we will utilize the gradient. We will utilize the gradient to identify the shortcomings. Okay, identify the shortcomings. The other structures are nearly same. Okay, a little bit different. We will see this what actually the different. But the philosophy is the same. So for the case of our gradient boosting, the shortcomings we will identify through the gradients. But in case of our AdaBoost, the shortcomings are identified by higher weight of the data points. So we can see the evolution of our algorithm. So AdaBoost at first proposed in 1996 and 1997. the updated version. And then the gradient descent also with a special laws that is proposed in this kind of the upgradation of our Adabust algorithm and Preyman in 1998 and 1999. And generalized Adabust gradient boosting, this is proposed by the Friedman 2000, and Friedman also updated in 2001. Okay, so that means from the Adabust, at first Adabust gradient descent, and then generalized Adabust gradient descent is proposed by different researchers. If we consider about the difficulty level, then the regression is easier in Adabust than maybe classification and then ranking. So we will discuss at first the regression and then classification. So now think about, we want to apply the gradient descent in regression algorithm. Okay, in regression algorithm. So regression actually to try to find out, try to predict the exact value or exact number or numerical values or numeric with plotting points. So for that, maybe you can say that is okay. We need to consider about weak learners, and then we will try to find out the strong learner. Okay? Let's say we have a data set. This is the data set. And in the data set, we have x1 and y1. It means this is our feature factor and y1 is the value. Okay. Similarly, for instance number 2, this is our feature factor and this is our target value. Similarly, maybe we have total n number of instances. Okay, n number of instances. So this is feature factor and n is our value. Okay. Like maybe you can consider about, okay, you want to find out that is the maybe a stock price. Okay, a stock price of any maybe any stock like Bitsimco Pharma, and then the stock price in maybe dollar, like maybe this is $50 something. Okay? And then different days also. Okay, the first day maybe in January 1, January 2, January 3, like this way. So it is given. Now you want to find out that is the stock price of Bitsimco Pharma maybe in December, maybe 30. Okay, so you want to predict that. What will be the value, this value? So it can be any values, like maybe it can be 50.5, okay, or maybe 49.6, or maybe 60.2. Okay, so that means based on the time series values, or maybe they based on some other factors also. If we consider the features, many other features we can consider for it. Then finally, we want just to predict this value. Okay, so this is our regression, and for that we want to apply the gradient boosting. Now, suppose your friend wants to help you to give you a model, that is the F. This F model, this model actually can predict the value. But you check this model and find model is good but not perfect. Okay, at first somehow you got a model, but that model it performs good but not maybe perfect, not the excellent. So there are some mistakes, like if we consider about, if in our test case, if we feed this model F is our model. If we feed the data set of maybe x1, okay, so this is, maybe we can say this is the data set of test case. So if we feed the x1, it will return 0.8. 0.8. It will return 0.8. But originally, the y1 is 0.9. The y1 is 0.9. So this is original value. Original value is 0.9. But our model, that means this model, predictive model, just predicted that this value is 0.8. So that means there are some errors. That means this is original value and this is the prediction. Okay? Similarly, for the maybe another day, there is X. If we feed the model the feature values, then it will return 1.4. And originally is y2 equal 1.3. Okay? So that means there are some the errors in the model, given model. So at first maybe we can build a model F, and that model actually are not perfect. Okay? So it has some, or it induces some errors. So that's why we need to make it perfect. Okay, we need to make it perfect. But this time we have some constraint. The constraint here is you are not allowed to remove anything from F. That means whatever you build in F, you cannot uh, remove anything from F, or maybe you cannot even change the F, any parameter of F. You cannot do any parameter tuning here in F. Then how can we improve the result? For that, actually what we have to do, this is our F of X. Then we need to find out the error of this model. And based on those errors, we can maybe create another model. Okay, we can create another model. And then we can add the predictions of F of X and the prediction of H of X to get a better result. Okay, to get better result. So maybe in this way, if we consider that we build a new model, this is the previous one, and based on the errors of this model, we build another model H, and then again we can say f x1 plus of hx1, maybe it will return y1. Okay, that is perfectly or correctly. Similarly, if x2 h of x2, it will return y2. So maybe this one is also perfect or correct. Sometimes we may not get this y1, y2 exact. Then what can we do? On that case, maybe based on the errors of our x1 and f of x1 and h of x1, we need to build maybe another model also. That is consider about the h2 of x1. Okay, so this is another model. So if this two model output is still erroneous, then we can build another model and add the result of this model to get the y1. Okay, get the y1. So in this way, maybe we can extend our model, and to find out the result, to find out the original result, we can add the results from f of x1, h of x1, h2 of x2, like this way. Okay, so h2 of x1 like this way. So those are in additive manner. So now say this is our model. Finally, f of x1 plus h of x1 equal y1. And then from here, what we can write, h of x1 equal y1 minus f of x1 from here. That is y1 equal f of h of x1, if we can consider about this. So here h of x1 equal, can write y1 minus of f of x1. Okay? Can write this. So in this way, maybe you can write h of x1, h2 of x2, hn of xn. Okay, so these are our model. Actually, we can see that if we can subtract f of x1 from the y, so y is the original value, and this is the original, and this one is our prediction. Okay, the prediction. So if we subtract these two, then we will get the residual. Okay, so actually the h1, h x2, h of sn, we need to build those models, build those models based on our residuals. Okay, residuals, that is o minus t. Okay, so next what we have to do, that is that we have to find out the residual, and based on the residual, maybe we need to construct another model, and that model will give you a little bit better results if we can add with the previous results. So here is this, that means if any regression tree like the H achieves this goal perfectly, can any regression tree? Most of the case you will not get that, okay? So maybe not. So that means for that case, maybe you need to add that is another, like not only the H1, but maybe that is you need to construct maybe the H2 also, okay? H2 also, H2 of X, one like this way. Sometimes maybe more than that, like that is the another model you need to create, that is H3 of X1 like this way. Yeah, so that means uh, many models we can combine here. Uh, I think we have already discussed this one. This is actually the residual. Okay. Now, how it's related to our gradient descent? Okay, how it is related to our gradient descent? So in gradient descent, specifically gradient descent is one of the algorithm, and it will try to find out the optimal parameter values. Okay. So it will find out the direction of increment or decrement by utilizing the gradient, or you can say just loss function we have. We need to take the partial derivative with respect to the parameters, and then based on those partial derivatives, it will guide us, that is whether we need to increase or maybe decrease the values to find out the actual or you can say optimal value. Okay, so here you can see that this is the theta. If we consider this theta is actually our learning parameter, and we need to find out our that is optimal value of the theta, then what usually we do, this is the theta, and then j is our loss function. Usually we take the derivative of the loss function with respect to theta. Okay, so with respect to theta, then this is called the gradient. Yeah, this is our gradient, and this gradient will tell us, gradient we can consider about the negative. Sometimes we will get the positive also. So whatever this, that is a negative or positive, uh, and then this gradient will tell us, that means whether we need to increase the variable values, this one, or maybe decrease the variable values. So if we get some negative, it means we need to increase the variable values to move to the optimal direction. If the gradient is positive, it means we need to decrease the variable values to find out our optimal value. So it will gradually, maybe you can say, move towards our optimal, if we consider this is our optimal value. Okay. So another parameter usually we utilize in our gradient descent, that is called rho. Rho is our learning rate. Okay, learning rate. So the learning rate, maybe it will control, that is how speedy you want to move, or specifically we can say the step size, your step size. Okay, your step size. The step size mainly controlled by this rho. Okay, because sometimes maybe you can, if we set this value rho equal 1, or you can say rho little bit higher value, then maybe you can overstep the optimal value. So that's why usually this learning rate we set like 0.01, or maybe less than that, 0.0001, like this way. Okay, so that maybe we can move slowly utilizing the tiny steps. Gradient descent also, sometimes we can instead of, maybe you can say uh, constant stepping, constant step size, the gradient descent and our learning rate, it will help us to uh, move those steps maybe in dynamic manner. That is initially maybe larger steps or longer steps we can take, but gradually we will take the tiniest steps. Okay, when we are very close to the optimal solution. So that's why gradient descent is important, specifically to find out the optimal parameters. And here in gradient boosting also, we will utilize this gradient boosting algorithm to find out the values, specifically the shortcomings uh, of our weak learners. Okay? Then, as I already mentioned, that we have to take the gradient of the loss function. So let's say we have a loss function that is called our sum of square residuals. Okay? Sum of square residuals, but not exactly the sum of square residuals. We can say it's kind of a pseudo residual. Okay? So in case of our sum of square residuals, what usually we do, this is original value minus a prediction, and then the square of that, it will give us the sum of squared. This is residual and squared residual. Okay, then summation is there, sum of squared residuals. It will provide us the sum of squared residuals like this way. But here, instead of taking this one, we want to take just divide by 2. Divide by 2. So divide by 2, it will provide us a mathematical benefit, and that's why we divide this one by 2. Okay? So that's why it is not originally the residual, but we can consider this one is just the pseudo residual, okay? Because residual is just only observation minus prediction. So let's say we have the loss function, and loss function is our sum of square residuals, but here we can see that we have utilized the pseudo residuals. Now, if this one is the loss function, let's say this one is our j. J is the summation of L of yi and f of xi. That means for all the case, here is the summation I. So here is the observation I and the prediction I. Here observation is our yi. Observation is our yi, and the prediction is our f of xi. Okay? This is the prediction f of xi. So then we can write this one as, this is actually our y minus f of x square divided by 2. So this is our loss function. Now we have to take the derivative of this loss function. So let's say this is j. This j is our this one. Then we want to take the derivative of j. J is this loss function, summation of I, Ly I f of xi, and delta f of x. Now it means that this L of y f of x is our y minus f of x whole square by 2. Okay? So f of x whole square by 2. So if we take the derivative of this one with respect to f of x, then what we will get? The derivative of this one with respect to f of x. Okay, so that means if we take the derivative of our j with respect to f of x, so what we will get? Y minus f of x squared divided by 2. Okay, so that means you can see the divided by 2, so half is there. Now y minus f of x whole square. So we are taking derivative with respect to f of x. So f of x whole square, that means that we have to take the 2 in front, and then we will get y minus f of x. This is a chain derivative, because instead of x we have y minus f of x. Again, we have to take the derivative of this part. Okay, this part. Y minus f of x. So if we take the derivative with respect to f of x again, then we will get there is y is 0 minus f of x. So f of x, we are taking derivative with respect to f of x. So this is 1. Okay. So now we can see this is 2. Here is the half. So the 2 and half, it will cancel out, and we will get that here is y minus f of x, and here is 0 minus 1. 0 minus 1 is negative 1. Okay. So that means we will get negative. We will get the negative. We will get the specifically we will get the negative of y minus f of x. Y minus f of x. Okay, so we will get this. So negative y minus f of x. What actually the y minus f of x? Y is our original value. F of x is our prediction, the predicted value. So yi, you can say yi minus f of xi. So that means for all the cases we will get original value minus predicted value. The original value minus predicted value is actually the residual. Okay, so that means it's negative residual. Okay, so this is negative of residual, negative residual. So negative of residual. So gradient here, the gradient means the negative of the residual. So the gradient here is the negative of residual. So that means now if we can think about our gradient descent of that case. So why here is f of x equal f of xi plus of h of x, but this h of x is actually yi minus f of x. Okay, h of x yi minus f of xi. So previously we have already seen this one. Okay, so here h of x1 equal y1 minus f of x1. Okay, so that is h of x2 y2 minus f of x2. So that means h of x1 equal y1 minus of x1. So that's why we can write this one here. That is f of x, f of xi, that is updated value of f of xi. It will be the previous value plus of h of xi. But h of xi, you can see this one is yi minus of f of xi. Yi minus of f of xi. Now yi minus of f of xi, here we can see yi minus of f of xi is actually negative of the gradient. Okay, so we can see this negative of the gradient. So here we can, for this one, we can write the negative of the gradient. Okay, negative of the gradient. So if we consider here one, that is the row, then it will map to our gradient descent algorithm. Okay, so that is, this is updated value. This is the previous value, and minus and d of j divided by d of j with respect to d of theta. Okay, theta. Here we consider that this row equal one. Row equal one. Here is this row equal one. But instead of one, we can consider again any row also. You know, any row value maybe 0. 0.00 something. So that means instead of considering the learning rate equal 1, we can consider any learning rate also in this equation. Okay, in this equation. So actually, we can say that the residual here we get, that is the negative of gradient. Negative of the gradient. So if we calculate the residual, that will be our negative of the gradient. It means this is the negative and our gradient is there. Okay, so this part, it will cover this part. So similarly, if we consider about fit H to residual, that means fit H to negative gradient, it will be the same case. And update F based on the residual, it means update F based on the negative gradient, because residual is our negative gradient. So now we will see that actually we will update F based on the residual. And that is the kind of update F based on negative gradient. Okay. So this is now it's easy, because every time we will calculate the residual. So if we just do the negative of that, then actually we are following the gradient principle. Okay, gradient principle. So in our algorithm, we will utilize this. So now gradient boosting algorithm. So what we have to do, we have to start with the initial model. So this is f of x, the initial model. So initial model can be any model. You can utilize even any other machine learning algorithm to find out the initial model, or the basic one is just find out the average. Okay? Find out the average here. Like summation of yi divided by n. So this is the very simplistic way to predict uh, uh, the numeric value. Okay? So that is the average. Find out the average. The average will be the simplistic prediction. Okay, so very simplistic prediction. So here, that's why this model is very simple model. And what it will do, it will just find out the average value. This is the initialization. Okay, the initialization. Then iterate until convergence. So what we need to do, we need to calculate the negative gradients. So negative gradients means what? Negative gradients means the residual. So we have to find out the residual. And then fit a regression tree, that is H. We have to find out the H to the negative gradients. So negative gradients is the to the residual. So we need to find out the negative gradients means the residual. And then based on those residual values, we will construct the regression tree. We will construct the regression tree H. And then we will update the model. Like F, it is previously defined model, that is this F, this F, this F plus of H. So then the newly constructed regression tree is H. So this is newly constructed regression tree, and this is our that is the base model F. And then this row is our learning rate. The learning rate can be 1 or it can be any values. It's better if we can set some, maybe the row is that is less than 1. Okay, so we will utilize this algorithm to find out the regression utilizing the gradient boosting. Now I think it's better if we can see an example utilizing those values. So let's say we have a data set that in this given data set, we can see there is age, place of living, and IQ score. So I think in our last lecture, we have also discussed it, or maybe we have discussed this one in regression tree construction, the same data. Can anyone recognize this data set that we have previously discussed regarding this data set also?
Yes, sir. We can recognize.
Okay. So consider that the same data set again, and we have here the 6 observations, and based on the age and place of living, we want to predict the IQ score. And again, the IQ score can be any fractional value also, like can be maybe 3.25 or something. Okay? So that's why we can consider this one as our regression problem, and we want to apply the gradient boosting regression for this case. Okay. So now, as in our algorithm of our gradient boosting regression, we have seen that to start with an initial model. It means we have to build the initial model, and the most simplistic initial model is just taking the average of yi, the average of yi. So here is also we will do the same. Okay? In this case, actually we have these two are our x, the x, and this is our y. Okay, this is our y. This is y. So x and y. So for first instance, like this one, for first instance, the x1, this x1 consists of specifically two values, 8 and values. Okay, so 8 and values. And y1 for that is 1. Similarly, x2 consists of 10 and city. Okay, 10 and city. And y2 is 3. Okay, for the second instance. So in this way, we have n, that is a total 6 instances, and where x6 will consist of, that is is 60 and place of living city, and y6 will be 2. Okay? Y6 will be 2. So now at first we can see there is our target variable is this one of the IQ score is our target variable, that is y target variable. So according to our algorithm, we have to find out the f of x, summing up the values of the target variable divided by n. So here we can see, so that means this is the y, so we have to sum up 1 plus 3, 4, 5, 9, and then 14, 15, 16. Okay, then we have to divide it by 1, 2, 3, 4, 5, 6, 6. So we can see the average IQ score we will get is 2.67. Okay, that is summation of this 16 divided by 6. Okay, so we will get maybe 2.67. So this one is our initial model. That is our F. So this is our F. This is our F. Now what we have to do, we have to find out the shortcomings. Okay, the shortcomings actually the errors. The errors means the residual. Okay? The residual. The residual here we can see this is the average IQ score. So that means this is considered, these are the prediction, and this is the original IQ score. So now original minus prediction will provide us the residual. Okay, original like this one is 1, and prediction is 2.66. 1 minus 2.66 or 67. It will provide us the negative 1.67. Okay, negative 1.67. Here is this. This is the residual. Okay. Similarly, next is 3 minus 2.67. It is, maybe we will get 0.33. Okay, 0.33. Here is the 0.33. Okay. Similarly, for instance number 3, 4, 5, 6, we need to find out the residual values. So these are the shortcomings. Okay, the true residual values. Now what we have to do? We need to find out the age. We already have the F. Now we need to find out the age. Age is on kind of regression tree. Okay, regression tree. But we need to build the age based on what? Based on this pseudo residual values. Okay, so that's why our data set will be like this now. Data set will be, this is age and place of living, and then these are the pseudo residuals. That means these values. Okay, there is errors. We need to build the age based on the errors. Okay, based on the errors. And now I think we know how to do that. If we want to construct the regression tree. Last lecture we have already discussed about it. So here is age, and this is place of living. So that means 2 variables we have. Now we have to construct our there is a regression tree. At first we need to find out the root of the regression tree, and to find out the root, we have to think about whether we should consider the age as the root or maybe place of living as the root. Now we can see, okay, think about the we need to find out that is which one we have to consider. But at first, if we think about the age, but we can see that all these are also numeric values. So that's why what we have to do, maybe we can consider many splitter here. Okay, many splitters. We can consider many splitters. So that means how can we find out those splitters? And that's why maybe we can say we have to find out the average of 2 consecutive numbers, average of these 2 consecutive numbers. Okay, so 9, then 11, and then 21, and then 32.5, and then that is the 47.5. So these are the possible splitters we have. And now we have to consider 9 as the splitter, and then find out the performance of that. 11 as the splitter, performance of that. In this way, we have to find out. So that's why considering this one is and the pseudo residual, these are the pseudo residual values. Considering 9 as the splitter. So if we consider 9 as the splitter, then we will get the left side scores and right side scores. And utilizing that, we have to find out the sum of square residuals divided by 2, because we want to utilize the pseudo. Okay, so that's why divided by 2. It means if we consider, I think we know, because in our last lecture we have already discussed, if we consider is less than equal 9 as the splitter, So then we have to pass each and every instances. So if we pass here this one, the first one, that age is 8. So 8 less than 9, is it true? 8 less than 9, is it true? Yes, it is true. So we can say we have to place 1 in our left side, okay? It's a true side. And then pass the 2 here. Then 10 less than 9, is it true? No, false. Okay? So that means observation 2 we have to place here. Similarly, if you have to pass 3, then 3 is 12. Here is 12. 12 less than 9. Is it true? False. So that means observation 3 we have to place here. Similarly, we can say the 30, that means 4 will be here. And then 35, then 5 will be here. And then 60, so that means 6 will be there. Now what we have to do, we have to find out that is the equivalent pseudo-residual number, okay? Pseudo-residual number. Here is for the first one it is negative 1.67. Okay? So here this one is actually negative 1.67, and for 2 it is 0.33. This is 0.33. Then for 3 it is negative negative 1.67, and then 4 it is 1.33. 0.33. And for 5 it is 2.33. 2.33. And for 6 it is negative 0.67. It is negative 0.67. Okay. Now we have to find out the average of this side. So average of left side, you can see it is left side. The average of left side, it will be the same as it's only one instance we have. It is negative 1.67. This will be the average. And we have to find out the average of right side also. That means we have to sum up all these and then divide by 1, 2, 3, 4, 5. Divide by 5. Okay. So from here we will get the right side average, and if we do that, then we will get 0.33. 0.33. Okay. So that negative 1.67 in right side we get 0.33, and that's what we have written here. Average PRS score of left side instance is negative 0.67. Average PRS score of right side instance is 0.33. Okay, now we have to consider those are our predictions. Okay? Those are our predictions. Those are our predictions. So now we have to find out at first the SSR, sum of square residuals. So what will be the sum of square residual for this case? Okay. For instance 1, so this is 1. The original value is negative 1.67. This is the original value, negative 1.67. 1.67. Then this is original. Then minus prediction, minus here minus. Then what's the prediction? The prediction is, this is the prediction for that. Okay, for instance 1. Prediction is also negative 1.67. So this is original minus prediction, then square. Okay, because some square residuals. And then for the instance number 2, you can see this is instance number 2. The original value is 0.33. And how about the prediction? Original is 0.33. The prediction is also, you can see this is the prediction, okay, 0.33. So 0.33 whole square plus, then for third instance is negative 1.67, negative 1.67. This is the original value. Minus what's the prediction? Prediction is this 0.33. Okay, 0.33 is the prediction. 0.33 is the prediction. So here the square of that. Yes. Similarly, what we have to do, we have to continue this one. That is the third, fourth one. Original is 1.33, 1.33 minus the prediction is 0.33, 33, then whole square, and plus, then for the fifth one, fifth observation, the original is 2.33, then minus prediction is 0.33, whole square, plus, the last one is negative 0.67, then prediction is minus 0.33. Okay? 0.33 is the prediction. So then if we do the math, then we will get some value. What we have to do, we have to divide it by 2. Okay? That is SSR by 2. We have to find out the SSR by 2. So that means the values we have to divide by 2. If we divide it by 2, then you will get this value, 5. Okay? 5. So similarly, so this is for S 9. Okay, so that means you consider the S less than 9 as the splitter, and you got the sum of residuals value is 5. Similarly, we have to consider 11 as the splitter. Okay, I think no need to explain the same thing again. In our last class, we have already discussed how to construct the regression tree. Okay. So then if we consider S11 as the splitter, you will get the sum of square residual by 2, that is pseudo residual we will get, that is 6. If we consider S21, then 3.67, and 32.5, then 5.625, and 47.5, you will get 6.4. 6.4. So that means now we can see from here which one is the minimum error. The minimum value is this one, 3.67, 3.67. And 3.67 we got for the splitter is less than equal to 21, is less than equal to 21. Left side value is negative 1.00000033, and right side prediction is 0.999967, like this. Okay, so that means if we consider the S, then we have to consider S less than 21 as the splitter. Now we have to go back and think about our another parameter, that is place of living. So for the place of living, again we have to find out that is the sum of the residuals for our variables. Okay, place of living, we can see the variable values. It can be village, it can be city. So for that, we have to consider like this is our data set, and then again the place of living equal village. If we consider this one is our splitter, then here is the true and here is false, and then this is observation 1, 2, 3, 4, 5, and 6. So considering this, we can see if we can see that there is first observation. This is village. Place of living is true. Yes, true. The first observation will be here. Then second observation here is the city. Place of living equal village. Is it true? No. For the second observation, this is false. So that means second observation we have to place here. Then third observation village. Fourth observation also village. So for the village, those are the true. Third and fourth. And the city, that means 5 and 6 will be in other side. Then the corresponding pseudo residual values we have to write it here. Like for 1, the pseudo residual is negative 1.67, and for 3, it is negative 1.67, so negative 1.67. And for 4, it is 1.33, 1.33. And then for this 2, we will get 2. 2 is 0.33, so 0.33. And then for 5 is 2.33, so here is the 2.33. And for 6 is negative 0.67, negative 0.67. 0.67. So now we have to find out the average of left side instances. You can see the average of these three values, and we have to find out the average of these three values also for right side instances. Okay? We can see there is the average you will get for the left side is negative 0.67, and average for right side you will get positive 0.67. Then considering this, if we consider to determine the sum of square residuals, then you will get 10.67, and then sum of square residuals by 2 to find 5.33. So that means considering place of living equal village, we will get the sum of square residuals by 2, that is 5.33. And as we can see, the place of living, it has just only two types of variable values, village and city. So just only one splitter will be enough, because if we consider place of living equals city, so that one is kind of the mirror of our place of living equal village splitter. So no need to consider about the mirrors. Okay. And in our last lecture, we also discussed about that is if the variable values are maybe many, like if we consider about the n numbers of different variable values. Okay. Then the total number of splitters we need to consider is 2 to the power n minus 1 minus 1. Okay, this one. Like here, if we consider 2, then here is the 2 minus 1 minus 1. That is, in this case, 2, 1 minus 1. So that is 2 minus 1. It's just only 1. So that means we have two types, village and city. That's why we have to consider just only one splitter. If we have another one like the village, city, and town, okay, village, city, and town, something, okay, city, then three types. Then on that case, 2 to the power n minus 1, that is 3 minus 1, and then minus 1. It is 2 square minus 1, that is 4 minus 1, that is 3. Okay, so we need to consider three splitters like this. Okay. So one times maybe we need to consider place of living equal village, then we need to consider place of living equal city, then we need to consider place of living equal maybe town, and then we have to compare the there is the sum of square residual values, and which one is the lowest one. Okay? The lowest one means the better one, because the lowest error we got from that splitter. Okay, now as we have just only one splitter here, and the sum of square residual here is the 5.33. That means if you consider place of living as the splitter, then we have to consider the splitter as place of living equal village. Now, from our dataset, we have just only two features. So we have to consider just only the sum of square residuals of these two features. We can see from age, the minimum we got is 3.67. And for place of living, we got the minimum is 5.33 or 5.33. So between these two, if we compare between these two, then actually the age induced the lowest error. Okay, so lowest error, that is 3.67. And for the age, we have to consider AS21, because among the other splitters, AS21 actually induced the lowest sum of square residuals. Okay, so that's why we have to consider that our regression tree, that is our age will be this one, is less than equal 21 or less than 21, whatever you consider as less than equal 21. And then in one side we will get the true, that is the yes, and in another side we will get the no, that is the false. And for the left side, the average we will get the average we will get the left side, we will get negative 1.000003. So that is kind of negative one. And for the positive, we can see this is the positive, so we can get maybe positive one. So that means 0.99999. It is nearly positive one. So that means this positive one. So this is our age. Okay, this is our age. So this is we can expand this this one also again, expand this one also again, because you can say S21 it will split our data set into two subset, and if we can say that okay, we will consider the threshold of our depth of the tree. Maybe you can say, if we consider it is maybe 3, then you have to consider to construct up to 3 depth trees. Okay, up to 3 depth trees. But maybe for this case, I have considered the threshold equal to. So that means on that case, that is the threshold equal to. So the depth here is 0. This is 1. So that means 1. Okay, 1 depth. It is kind of our stumps only. So we want to construct the stumps here. But in gradient boosting, actually you can construct not only the stumps but any the regression tree of any depth. Like you can consider the threshold is 2 or maybe threshold is 3. Each and every tree will be on that case. Maybe the depth is 3 or depth is 2. Okay, so this is our the first H. Okay, this is, we can consider this is our H1. H1. Okay, we can consider this is H1. And for that, in our case, H1 is left side -1 and right side is +1. Okay, so now if we want to build a model, that means we can see f of, if you can remember this one, f plus h, there is rho h, okay? H, rho h, f plus h. So this is our h, and we have f, the average value, okay? And rho is our learning rate. Rho is our learning rate. So this is the model. Now what we have to do, we have to find out the prediction of our model. The prediction of our model. So that means A is place of living, IQ score, the average. This is our F. And previously we have determined the pseudo residual. This is the pseudo residual 1. Previously we have determined this one. Now we want to measure the predicted IQ score. Okay, predicted IQ score utilizing this model. And in this case, we have not only F, but we have also the H. And we have to consider the rho, maybe some values. Okay. So now we want to consider, that is to find out our the predicted field, the predicted IQs, predicted IQs. If we pass this observation, first observation, this age is 8. Okay, so pass it here. Then the age, we can say, is 8 less than 21. Is it true? Yes, true. True means this side. Okay, so this side, that means here is the -1. So on that case, it will be 2.67 plus of the learning rate here, the learning rate, and times what we got here is -1. So -1, the -1. So that means we can see 2.67 minus 1. It is the predicted IQ score will be 2.67. Learning rate is what we consider the learning rate is 1 or 0.1. 2.7. The learning rate is a -1. 0.1. Okay, we have considered learning rate here. This I should write it here, 0.1. Okay, so considering that, then we will get what, 2.67 minus 0.1. It is 2.57. Okay, here it is 2.56667. 2.57. Similarly, we have to pass the next instance, that is next is 10 here. That is 10. Again, we can see we have to pass this second observation. Then it will check the age, and now the age is 10. 10 less than 21. Is it true? Yes, true. True means this side. Okay, so we will get the negative. Again, we can see this is 2.67, 2.61 plus the learning rate 0.1, 0.1.
স্যার আমরা এখানে -1 কিভাবে পাচ্ছি?
সেটাই তো বলতেছি কিভাবে পাচ্ছি। এখানে এটা পাস করতেছি, সেকেন্ড অবজারভেশন পাস করি, এটা পাস করলে এখানে তো 2.67ই থাকবে না, প্লাস লার্নিং রেট যেটা সেটা 0.1 হবে। এখানে যদি আমরা এখানে কি এজ চেক করতেছে, এজ কত তার 10 না, তাহলে 10 লেস দ্যান 21, এটা কি ট্রু? ট্রু হলে কোন এই সাইডে যাচ্ছে, তাই তো, সেখান থেকে যে -1 পাচ্ছি। ঠিক আছে, আচ্ছা, ওকে। So that means again we will get the negative point.
স্যার সব ক্ষেত্রে ট্রু হলে -1 নিতে হবে নাকি এটা কোশ্চেনে দেওয়া থাকবে?
এটা তো ট্রি তে যা আসবে তাই, যদি লেফট সাইডে যায় তো অলওয়েজ -1, রাইট সাইডে গেলে +1 আসবে। ট্রিতে এটা তো ওকে। সো ট্রি থেকে যেটা পাবো সেটাই অলওয়েজ তাই, ট্রি যেটা রিটার্ন করবে আমাকে। Okay, then if we consider last one, that is 6. What's the age? Age is 60. Okay, so what we will get for this? That is predicted IQ score. What we will get? In this case, it is F. F is 2.67. 2.67 plus learning rate is 0.1. As we decide, the learning rate is 0.1 here. And then we have to pass the 6 here. If we pass the 6, the age, it will get 60. So 60 less than equal 21. Is it true? No, false. So false means it will move in this direction. And we can see here 1. So prediction is 1. So this is 1. What will be the value? 2.67 plus 0.1. 2.67 plus 0.1 is 2.77. So we will get 2.77. So here is this. You can see this is the 2.77. Okay. So that means this will be our predicted IQ score. Now, okay, the predicted. So we have the prediction now. That means we have the prediction for F plus row H. But now we have to analyze, or we have to test, we have to determine the errors, if there is any error or not. Because previously we have a model F, then we have added H. That if still there are some errors, then we have to continue to add new trees. Okay, so that's why we have to find out the pseudo residual as the 2. That means second time. So we can see that is original IQ score is 1, and prediction is 2.57. Original minus prediction is this one, -1.57. Original IQ score is 3, prediction is 2.57. So 3 minus 2.57 is 0.43. Okay. Then original is 1, prediction is 2.57. This is negative. Similarly, original is 2, and prediction is 2.67. That is -76. And negative 0.76. So these are our pseudo residual 2. And now we can see that still errors are there. So we have to continue the iteration. বলেন
স্যার এটা কি সুডো রেসিডুয়াল হবে নাকি মানে রেসিডুয়াল হবে? কারণ সুডো রেসিডুয়াল এটা তো স্যার 2 দিয়ে ডিভাইড করা হয়, তাহলে এটা কি সুডো রেসিডুয়াল নাকি মানে নরমাল রেসিডুয়াল?
আচ্ছা, এখানে আমরা হচ্ছে ওই রেসিডুয়াল যেটা নেগেটিভ অফ দ্য রেসিডুয়ালটাকে গ্রেডিয়েন্ট বলতেছি না।
জি স্যার।
আর ওই গ্রেডিয়েন্টটা পাইছি কিভাবে? সুডো ইউজ করে না।
জি স্যার।
সেই জন্য সুডো লিখতেছি আমরা।
আচ্ছা
কারণ আলটিমেটলি আমরা হচ্ছে এটা কি ক্যালকুলেট করতেছি গ্রেডিয়েন্টটা। গ্রেডিয়েন্ট মানে আমাদের নেগেটিভ অফ রেসিডুয়াল। আর নেগেটিভ করতে গিয়ে আমরা কি করছি, এটাকে 2 দিয়ে ভাগ করার পর আমরা হচ্ছে আলটিমেটলি গ্রেডিয়েন্টটা নিচ্ছি, যাতে করে ওই যে হাফ যেটা আসে হাফটাকে কেটে দিচ্ছি আমরা, সেজন্যই বলতেছি। ওকে
জি স্যার।
okay then so these are the values. Then next what we have to do, so now this is our data set. Okay, so this is our data set. Now if we consider this as our data set, so we want to find out the next age. So that means we can say that now we want to find out f plus row age plus another row age. So we can consider previous one as h1 and this one as h2. So we want to find out the h2 now. We want to find out the h2. So from this data set we will get the h2, and then again we can see the same variable we have, age and place of living. So again we have to find out the splitters. Okay? That is 8, 10 splitter, 9, 10, 12 splitter, 11, 12, 30 splitter, 21. So again we have to consider is 9 as the splitter, 11 as the splitter, 21 as the splitter, 32.5 as splitter, 47.5 as the splitter. Okay? And then left side instances, okay, and then the right side instances average, okay, and find out the sum square residual value. So here is our pseudo residual. So 4.624. Okay, 4.624. Similarly, we have to check this everyone. Okay, 11, 21. We will get this value. And now which one provide us the lowest residual, pseudo residual? Then we can see this is 3.67. This is the minimum one, and again this is 21 as 21. Okay, this 21. So that means again, if we consider the age variable, then we have to consider age less than 21. But we have another variable, place of living, so we have to test it, and we can see if we find out the SSR by 2, then here is it 4.89. Okay, 4.89. Now we have to compare between these two. Previously we have 3.67 and here is 4.89. 3.67, here is 4.89. That means is induced the minimum sum of the square residual by 2. So that's why we have to consider the age. And if we consider the age, then that means we have to consider age 21. Age 21. Is for S21, the left side instances average is negative 0.9 and right side average is just positive 0.9. So that's why you can see that this is the left side average, this is the right side average. The negative 0.9 and positive 0.9 is less than equal 21. So that means this is our new regression tree, that is H2. Okay, H2. So now the learning that is model, it will be the F plus of row H1. This is our row H2. Okay. So now considering this learning model, we have to again find out our predicted IQ score. Okay? Predicted IQ score. So this is the pseudo residual 2 we have already discussed maybe up to this one, and then now we have to find out the predicted IQ score for this. And again for that we have to pass each and every instance, like our first instance here where age is 8 and place of living equal village. Okay. And if we pass this one here, then we can see at first the f is our 2.67 plus the learning rate is 0.1 times. Then if we pass this instance here, then 8 less than equal 21. Is it true? Yes, true. That means the negative 1, 1 times negative 1 plus this plus. Then again learning rate is 0.1. And here is H2. Then again is 8 less than 21. Is it true? Yes, true. Then you have to move in this direction. And this is negative 0.9. We get negative 0. So this will be our predicted IQ score. Predicted IQ score. So that means for the first case, if we do the math, then we will get this value. Okay, 2.47. 2.47. Similarly, for each and every instance, we have to just calculate those values. And then after calculating the predicted IQ score, we have to find out the pseudo residual free. This is IQ score, you can say, original IQ score, and then maybe we have to subtract the predicted IQ score. Then we will get the residual. Okay, so negative 1.47. So in this way, we can see there is actually those are our residuals. Those are our residuals, and still we didn't get that is the maybe nearly 0. Okay, nearly 0. We didn't get that, so we have to continue. Okay, we have to continue this way. So what will be the stopping criteria? The stopping criteria will be the threshold. Okay, so that means if we consider that the threshold will be the pseudo residual value, it will be less than uh, we can say the absolute value of the pseudo residuals is less than maybe 0.001. Okay, so if we consider this one as the threshold, 0.001. Okay, so that means it is negative 1.47. So the absolute value is 1.47. So it is still far from the 0.007. Okay? So that means we have to do many iterations. Okay? So in this way, we can maybe find out our gradient boosting regression. So one of the stopping criteria could be the threshold, and another stopping criteria could be how many boosting trees you want to construct. Maybe on that case, that is the kind of boosting trees, how many you want to construct. Maybe the number of boosting trees you can construct, it is like 1000. Okay? So after construction of 1000 boosting trees, either you can stop or maybe you can follow another stopping criteria utilizing the threshold. Okay? Absolute pseudo residual values will be less than the threshold. Okay? So if you can get for all the cases, then maybe you will stop iteration. So this is how the regression, the gradient boosting for the regression is utilized. Okay, now the question is, maybe you set the threshold that okay, you want just maybe just only two boosting regression trees. Okay, two boosting regression. So that means on that case, the 2 means we have to stop here because we have already find out the H1 and H2. Okay? Now is given that okay, a test case is there. That means one person is as a test case is given. Test case is given that one person, that is the age of that person is 34, and the place of living is village. We want to predict the IQ score of this person utilizing your gradient boosting or regressor. What will be the IQ score? So that means this query or test case we have to pass to this model. Then for this case we can see 2.67 will be there. F plus learning rate is 0.1. And then the age of this person is 34. Okay, so 34 less than 21. Is it true? False. So that means it will move in this direction. Here is 1. So that means we can say it will be positive. Okay, positive. And then again we can say plus learning rate again 0.1. So 0.1 is the learning rate. Again here is 34 less than 21. Is it true? False. So that means we have to move in this direction. Then this is 0.1. Okay. Okay. So that means it will be 2.67 plus 1 times 0.1 is 0.1 plus 0.1 times 0.9 is 0. 0.09 and 0.09. It will be 2 point. It will be 2 point. Then 8.6. So this will be the predicted IQ score for that person, 2.86. Okay. So this is how we can utilize gradient boosting for regression. So do you have any question now?
স্যার 0.009 কেন আসলো?
0.09
একদম শেষ লাইনটাই। এখানে স্যার শেষ লাইনটাই 2.67 প্লাস 0.1 প্লাস 0.9 এখানে শুধু 0.9 আসার কথা না?
স্যার শোনা যাচ্ছে না হয়তো।
হ্যাঁ, কোশ্চেনটা কি ছিল আমাদের জন্য?
স্যার এখানে একদম শেষের লাইনটা 0.09 কেন আসলো? শুধু 09 আসার কথা ছিল না?
0.09 এর শুধু
মানে শুধু 0.9 আসার কথা ছিল না, কিন্তু এখানে 0.09 কেন আসলো?
0.1 না?
জি,
0.1
ও
greater
আচ্ছা
than
আচ্ছা
1.
আচ্ছা 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 সরি।
স্যার আমার একটা কোশ্চেন ছিল।
হ্যাঁ, বলেন।
স্যার আমাদের স্টপিং ক্রাইটেরিয়া হিসেবে যদি সুডো রেসিডুয়ালের থ্রেশহোল্ড ধরে, তাহলে যদি এরকম বলে যে সুডো রেসিডুয়ালের থ্রেশহোল্ড 1 হতে হবে, এক্ষেত্রে কি এরকম হবে যে সব কয়টা ভ্যালুর জন্য সুডো রেসিডুয়াল 1 এর চাইতে নিচে আসতে হবে, সেই ক্ষেত্রে আমরা স্টপ করবো, এরকম?
হ্যাঁ, সেটা চাচ্ছি আমরা। সবকটার জন্য এরর যেটা, সেই এরর যেন মিনিমাইজ হয়। সেই মিনিমাইজটা হচ্ছে আমরা থ্রেশহোল্ড একটা সেট করব যে 0.001 এর চাইতেও ছোট হবে, তাহলে সবকটার ক্ষেত্রেই ভালো আউটপুট পাবো আমরা। এনি আদার কোশ্চেন? Okay, I think we will discuss our classification after the midterm. Okay, gradient boosting for classification. So that means your midterm syllabus will be up to the gradient boosting regression.
স্যার সামনের উইকে কি আমাদের মিড টার্ম হবে?
হ্যাঁ, সামনের উইকে midterm. তাহলে
স্যার
midterm এর
কানেক্টে
জন্য
যে টাইম দেয়া
syllabus,
আছে,
হ্যাঁ
স্যার কানেক্টে যে টাইম শিডিউল দেয়া আছে ওই টাইমে তো হবে।
হ্যাঁ, টাইমে ওই টাইমে। ওকে, তাহলে আমাদের সিলেবাস কি কি থাকলো মিডটার্মের জন্য? সিলেবাস টার্মের জন্য আমরা তার আগে প্রাইভেট হচ্ছে SMS আমরা খুব বেশি কিছু তো পড়িনি না। কি পড়লাম? হ্যাঁ, এই তো একেবারে বেসিক। তারপর র্যান্ডম ফরেস্টের ওখানে আমরা ট্রি কনস্ট্রাকশন শিখেছি। তারপর র্যান্ডম ফরেস্ট কনস্ট্রাক্ট করছি। র্যান্ডম ফরেস্টটা বিভিন্ন ভেরিয়েশনে, ঠিক না? দ্যাট মিনস আমরা যদি আমাদের ভেরিয়েবল ভ্যালুস গুলা যদি ক্যাটাগরিক্যাল হয়, তারপর ভেরিয়েবল ভ্যালুস যেগুলা সেটা যদি আমাদের নিউমেরিক হয়, তারপর এন্ট্রপি হলে কি হবে, তারপর হচ্ছে আমাদের জিনি ইম্পিউরিটি দিয়ে কিভাবে ক্যালকুলেট করা যায়। এরপর আমরা পড়ছি হচ্ছে রিগ্রেশন ট্রি। তারপর পড়লাম আমরা হচ্ছে শিখলাম অ্যাডাপটিভ বুস্টিং ক্লাসিফায়ার, আর আজকে শিখলাম গ্রেডিয়েন্ট বুস্টিং থিওরি আর গ্রেডিয়েন্ট বুস্টিং ক্লাসিফায়ারের রিগ্রেশন অ্যালগরিদম। Okay, I think that will be our midterm syllabus.
স্যার একটা জিনিস হচ্ছে স্যার রিকল করতে ভুলে গেছি, সেটা হচ্ছে স্যার ওই এনট্রপি আর যখন গিনি ইম্পিউরিটি দিয়ে আমরা স্যার সলভ করছি, স্যার আপনি
হ্যাঁ।
বলছিলেন যে স্যার কোন কেসে গিনি ইম্পিউরিটি পারফর্ম করবো আর কোন কেসে স্যার এনট্রপি পারফর্ম করবো, সেটা একটু রিপিট করা যায়?
আচ্ছা, এখানে হচ্ছে এন্ট্রপি আর গিনি ইম্পিউরিটির মধ্যে আমি বলছিলাম যে আমরা ডিসিশন ট্রি সাধারণত যদি এরকম হয় যে আমরা শুধু সিঙ্গেল ডিসিশন ট্রি নিয়ে কাজ করি, তাহলে সেই ক্ষেত্রে হয়তো এন্ট্রপি দিয়ে কাজ করা যায়। কিন্তু যখন অনেকগুলো ডিসিশন ট্রি কনস্ট্রাকশন করতে হয়, যেটা কিনা র্যান্ডম ফরেস্ট, অ্যাডাবুস্ট, গ্রেডিয়েন্ট বুস্টিং, যেখানে অনেক ট্রি কনস্ট্রাকশন করতে হয়, তো সেগুলোর ক্ষেত্রে আমরা হচ্ছে আমাদের ইম্পর্টেন্ট হচ্ছে আলটিমেটলি সেখানে যে টাইম কমপ্লেক্সিটি যেটা, সেটা একটা মানে ইস্যু আর কি। তো যেহেতু এন্ট্রপিতে আমাদের লগ ক্যালকুলেশন করতে হয়, প্লটিং পয়েন্ট অপারেশন যেটা সেটা বেড়ে যায় সেখানে। আর আমাদের হচ্ছে সেজন্যই আমরা জিনি ইম্পিউরিটি যেটা সেটা হচ্ছে ইউটিলাইজ করি। তো এখানে ডিসিশন ট্রি কনস্ট্রাকশনের সময়ও জিনি ইম্পিউরিটি ইউজ করা যায়, আবার এন্ট্রপি ইউজ করা যায়। কিন্তু সাধারণত আমরা দেখি যে অ্যালগোরিদম যেমন ID3 অ্যালগোরিদম এটা এন্ট্রপি ইউজ করে। আবার যদি কার্ট ইউজ করি আমরা, যেটা আলটিমেটলি আমরা অ্যাপ্লাই করছি কার্ট অ্যালগোরিদম, তো সেখানে জিনি ইম্পিউরিটি অ্যাপ্লাই করে। তো ওভারঅল বলতে গেলে যদি আমরা শুধু একটা ট্রি কনস্ট্রাকশন করি তাহলে হয়তোবা জিনি ইম্পিউরিটি অথবা এন্ট্রপি যে কোনোটাই ইউজ করতে পারি, কিন্তু যখন অনেকগুলো কনস্ট্রাকশন করতে হয় তখন জিনি ইম্পিউরিটি ইউটিলাইজ করা বেটার।
Yes, sir. Got it. Thank you, sir.
আসসালামু আলাইকুম স্যার। স্যার
ওয়ালাইকুম
মিড
আসসালাম।
কোশ্চেন কি ম্যাথ রিলেটেড হবে নাকি শুধু স্যার থিওরিও থাকবে?
থিওরি এবং হচ্ছে আমাদের সিমুলেশন, দ্যাট মিন্স ডেটা সেট দিয়ে সিমুলেশন
জি,
যেভাবে
জি, জি।
এক্সাম্পল আকারে দেখাই প্রত্যেকটা,
হুম,
সেটাও
হুম।
থাকবে। এটা 40-50 থাকতে পারে, অথবা 40% থিওরি আর 60% আমাদের ম্যাথমেটিক্স বা ডেরিভেশন হতে পারে।
জি, জি, ঠিক আছে। থ্যাংক ইউ।
স্যার মিডটা 20 মার্কসের হবে নাকি?
আমাদের ইনিশিয়ালি যেটা প্ল্যান ছিল ওভাবেই হচ্ছে হয়তোবা যাব আমরা। আপাতত হয়তো 25 মার্কসের এক্সাম নেব।
জি, আচ্ছা।
স্যার কয়টা কোশ্চেন থাকতে পারে?
3টা কোশ্চেন, 10, 10 and 5। ওকে, তাহলে সবাই ভালো থাকেন, বাই। Again, attendance for all. Okay, thanks everyone for joining this session. See you in our next class in our midterm exam. Okay, thank you.
Thank you, sir. Assalamu alaikum, sir.
Walaikum assalam.
Assalamualaikum, sir.